Okay, good morning, afternoon, or evening, everybody. Welcome to the NASA Earth Data webinar, Discover Earth Science Data with NASA Earthdata Search. This is your host, Jennifer Brennan. So while everybody is logging in, we do have two optional polls at the bottom of the page, and we do appreciate your feedback on those. So thanks so much. I've got 2 p.m. Eastern Time, so I'd like to go ahead and get started. What we'll do first is go over a few housekeeping items related to this webinar. Okay, so due to the large number of participants and also to ensure the best audio experience, the conference has been placed in silent mode. However, if you have any issues or you have any questions, what I'd like for you to do is enter those into the Q&A pod located in the lower right-hand corner of your screen. This works like a chat. The webinar itself will be recorded and posted to our Earth Data Adobe Connect catalog, as well as to our NASA Earth Data YouTube channel. The URL will be provided to you at the end. All presentation files will also be available for download at the end of the webinar. The webinar is 1 hour long. 45 minutes are allocated to the presentation and live demonstration. And then another 15 minutes for the question and answer period. After the speaker has finished his presentation, what we'll do then is we'll move to a final set of polling questions. The question and answer period will follow directly after the final polling questions. As I mentioned earlier, you will have an opportunity to ask your questions throughout all portions of the webinar, except during the live demonstration by using the Q&A pod. Due to the large number of participants, we won't be taking any questions using the raising hand function. This has been disabled. Again, we'll take all of the questions at the end using the Q&A pod. But another note, not to worry, if you ask a question at the beginning prior to the live demo, the Q&A pod, the feature, the information is persistent. So that question will have been captured and we will most certainly address it at the end, okay? One final note, depending upon the volume of questions that we do receive, we will extend the Q&A period an additional 15 minutes to 3:15 p.m. Eastern Time for those of you who wish to stay on the line. What I'd like to do next is move to our agenda. The first 10 minutes or so will be dedicated to an overview of NASA's Earth Observing System, Data and Information System, and I will also touch upon a couple of key data discovery and data access tools. Next, I'll turn it over to our speaker who will provide a tour of the NASA Earth Data Search application, highlighting key features and functionality while taking participants through a step-by-step use case where he will access some MODIS snow data for the recent snowstorm. With that, I would like to kick off today's webinar with an introduction. All right. Okay. So what I wanted to do is, in order to really frame the content for today's webinar, I'd like to provide you with an introduction, especially for those of you who may be beginners to NASA's EOSDIS data holdings. So NASA EOSDIS provides end-to-end capabilities, and this includes your data processing, your data management, archival, and distribution for, several thousand NASA Earth Science data products. And they come from a variety of sources. So we're talking about satellite data, aircraft data, field campaign, and various other programs. There are 12 discipline-specific DACs, or Distributed Active Archive Centers, that process, manage, archive, and distribute these. All right, there we are. This next chart shows you where our 12 DACs are located, and you can see actually that 4 of the 12 are located here at Goddard Space Flight Center. So we've got the Crystal Dynamics Data and Information System, the MODIS Level 1 Atmosphere Archive and Distribution System, the Goddard Earth Science Data and Information Services Center, and also the Ocean Biology DAC. All right, so now, I'm sorry about that. Let's talk a little bit about our data. I want to give you a sense as to what a beginner needs to know at a very high level about our data products. As I mentioned earlier, the Earth Science data really do range from not only near real-time data sets to airborne and satellite data products. We have a number of field campaign data products and also human dimensions data as well. Most of our data is freely available and publicly accessible online. With respect to temporal and spatial coverage, this really is dependent upon the platform, the sensor, the campaign, and in many cases, the data product itself. That being said, it is true that for some satellites, NASA has historical satellite data beginning from the mid-1970s through the present. Okay? As far as data format is concerned, most of the NASA EOS satellite data is in the hierarchical data format, or HDF data format, or HDF, pardon me, Earth Observing System, also referred to as HDF EOS format. Pardon me. What I've done here is provided a link for you to those of you who may be interested in finding out a bit more about the HDF or HDF EOS data format. That's not to say that other data formats are available. There are, including NetCDF, binary, ASCII, GeoTIFF, KML, and more. And an important note for everybody, today's GIS packages can easily read and visualize this format. Not only that, but there are a variety of NASA DAC developed or other tools available to end users that would allow you to process and convert the data into GIS or other formats. Hopefully this will go slower. All right, there we are. Okay, so now you might be wondering, what types of data do we have and for your research or applications needs? And so I've provided you with just a few basics, and what I'll do next is give you some information about the disciplines and also the measurements for our data products. So the next several slides will outline the disciplines and highlight many of the parameters or measurements for which we have data. And I should note that these are not comprehensive lists, but they're rather designed to outline data availability. So on each discipline slide that follows, I've included links. Sorry, it's very touchy today. See what happens when the host tries to give part of the presentation? Okay. All right. So on each discipline side, what I've got is I've included links to resources that will provide you further information to be able to explore the specific data product. So let's begin with our near real-time data. The Land Atmosphere Near Real-Time Capability for EOS, and the acronym for that is LANCE, provides free access to global Earth science data and imagery within 3 hours of observation. The data for the following instruments that you see in the second paragraph that are available currently come from the AIRS, AMSR2, MLS, MODIS, VIIRS, and OMI instruments. Near real-time imagery is generally available 3 to 5 hours after observation. And again, I have included the link below. These slides will be available at the end as well. All right, as far as atmospheric data is concerned, there are many different parameters that are being measured, and again, this is not an exhaustive list, so including things such as cloud properties, aerosol optical depth, precipitation, lightning, chemistry, surface air temperature, and other atmospheric dynamics. The primary DACs specializing in distributing the atmospheric products are the Atmospheric Science Data Center DAC and the Goddard Earth Science Data Information Services, or EOSDIS DAC, and then also our MODIS Level 1 Atmosphere and Archive Distribution System. The latter two, both at Goddard. Okay, I've included here your links for the Atmosphere Discipline Dataset Reference Sheet, which will provide you with much more detailed information, including long names for data products that fall within the atmosphere discipline, and then also the entry or the discipline page within our earthdata.nasa.gov website for finding out more information about atmospheric data products. And then you've got your DACs listed below. Okay, and moving along to cryospheric data products. Again, the parameters that are measured here, we're talking about snow, land, and sea ice. We've got measurements that include snow extent, the snow water equivalent, snow depth. Sea ice includes your sea ice extent, concentration, motion, for example, so your sea ice vectors, and then also land ice, including ice sheet topography, ice sheet volume change. The two DACs that specialize in distributing cryospheric data products are the National Snow and Ice Data Center DAC, and then also our Alaska Satellite Facility DAC. And I should note that For all of the disciplines, there are numerous DACs, with the exception of the core DACs, that are also distributing products as they relate to their discipline, okay? So there could be cryospheric data products at other DACs, for example. And by checking out those data set reference sheets, you'll really get a better feel, excuse me, as to what's available. All right, moving along here. And for some reason, it is having trouble. All right, human dimensions data products. So many of you may not realize that NASA actually has a socioeconomic data and application center that holds a variety of socioeconomic data. And really this DAC is there to integrate socioeconomic with remotely sensed Earth science data. So you're talking about measures like gridded population of the world data products, environmental treaty data products. They have a natural disaster hotspot data set along with biodiversity and a number of these actually, and ecosystems data products. And again, you'll find the similar information, the reference sheet, the entry page for that discipline, and then the DAC web page. All right, land processes data products. So here we're talking about two different programs. So it's broken into two programs, I should say. Your land cover, your land use change, or land surface, and then also solid earth. And for those measurements, we're talking about parameters being measured such as your land surface temperature, vegetation cover like NDVI, phenology data, land cover characterization, and more than that as well. We have a number of digital elevation models, for example. Solid earth measurements include gravity, geomagnetism, and tectonic data. The primary DACs that specialize for the solid earth would be the Crustal Dynamics Data and Information System, then following our Land Processes DAC and the Oak Ridge National Laboratory DAC. And I should note that the Oak Ridge National Laboratory DAC has a number of very temporally and geographically specific data products for field campaign data, okay, along with some land validation data products as well and a model archive. So that's some interesting information for you to take away. All right, ocean data, also divided into two disciplines. So we've got our ocean biology and biogeochemistry program, and then physical oceanography. So for your physical oceanography, we're talking about wave height data, sea surface height, sea surface temperature, near surface wind data, for example. And then for your ocean biology, we're talking about measurements such as chlorophyll concentration, your ocean color data products. And the two data centers that are really responsible for distributing these products for physical oceanography is our Physical Oceanography DAC. And then for ocean biology, the Ocean Biology DAC here at Goddard Space Flight Center. And moving along here, I've got the craziest thing going on with the PowerPoint today. All right, so now let's talk a little bit about where should you start with so many different NASA sites and NASA data access tools out there. I've included just a few. This is not an exhaustive list, the first being the NASA Earthdata Search tool. This really allows you to search thousands of data sets in one interface. And I think one of the benefits is that you are able not only to discover the data, but search, subset, visualize all in one interface across the DACs. Okay, there are multiple filtering and subsetting capabilities available. The second is more of your data discovery tool, the NASA Global Change Master Directory. So it's kind of like a card catalog, if you will, for not only NASA's data products, but you have information about data products that have been submitted by universities, other agencies, etc. I touched upon the LANCE tool, which is, again, accessing your near real-time data products. And then finally, NASA Worldview, which allows a user to interactively browse global Earth science satellite data. You'll be able to download the imagery and also the underlying data from over 100 data products. What they've recently added is a capability to add layers or to filter according to natural hazard or science disciplines. So you may want to check that out at some point. All right, with that final note, I would like to tell you that these services are all available by going to the Data Discovery tab of the top hat portion of the earthdata.nasa.gov website. And I would like to turn it over and introduce our speaker today, Patrick Quinn, who is the lead developer for NASA Earthdata Search. Patrick?
Okay, thank you, Jennifer. So as Jennifer mentioned, I'm Patrick Quinn. I'm the lead developer for Earthdata Search, and I'm going to be talking about Earthdata Search, and I'm going to be using a use case, talking about a use case with a recent snowstorm. But first, I want to actually go into depth about what happened here. So just a couple weeks ago, from January 22nd to the 24th, the U.S. East Coast was pounded by a Category 4 winter storm named Jonas. It was a large storm. It was the fourth most severe storm to hit the region since 1950, and over 28 million people got at least 14 inches of snowfall in those 3 days. Only twice since 1900 have more people received as much snow. During that period of time, the coastal areas would receive gusts, sometimes reaching 90 miles per hour, and in the aftermath, there were thousands of people in the region, most of whom were children, would be pelted by balls of compressed snows for days to come. So that's a lot of data. And even that data is very highly distilled from the huge amount collected on the event. But what was the nugget of information that was actually critical for my needs? Well, for me, it was that my 12-inch corded electric snowblower is woefully inadequate for this sort of thing, which I discovered fighting for hours trying to dig us out. And digging out is probably not ever a way that you want to find yourself describing a snowblower. So anyways, I'm going somewhere with this. Really, this anecdote that I'm telling is a microcosm for what I feel is one of the biggest challenges facing today's Earth scientists. Namely, you're faced with an absolute fire hose of data. All of this data that Jennifer was talking about, literally petabytes over many millions of files. How do you sift through that to get that useful kernel of information that you're interested in? How do you avoid spending hours downloading gigabytes of data only to find clouds covering the land area that you were interested in seeing? And how do you find well-vetted derived data and avoid spending days or more doing your own ad hoc compositing and aggregation? How do you discover the services out there that make it possible for you to get the data you're interested in, and only that data, in a format that you're most prepared to deal with? So these are kind of the big overarching questions that Earthdata Search tackles. Earthdata Search is a modern, highly visible web application to help you search, discover, visualize, refine, and ultimately access NASA Earth observation data, as well as data from international and interagency partners. And so for the remainder of this webinar, we're going to take a look at what it can do. All right. Gotta love a live demonstration. Okay, so this is the Earthdata Search website. This is the home page. And we have a very simplified home page here. It starts with a simple box asking you to enter your either search for collections either by keyword or filter by time or space. There's also the option to browse more data if that's if you're interested in searching more in a guided manner. On the right-hand side here, you see a window that pops up that allows you to take a tour of the site. So if you're trying to remember some of the things that we talked about in this webinar, or you're trying to get a feel for the site starting out, you can go through the tour and it'll guide you through a simple data investigation. But for now, we're going to use Earthdata Search to to get something useful about the snowstorm that I mentioned. So there are many useful investigations that we could perform here about the storm, but in this case, I want to try to go simpler. So for instance, going back to what Jennifer was saying about the sorts of data that are in the EOSDIS holdings, there are some questions as to whether the abnormally high Atlantic sea temperatures caused storms to have increased in severity over the past few years. You might have questions about how snow melt might affect the region's hydrology, or even look into studies about how it affected populations. But for this webinar, what I want to do is just try to get some useful data for exploring a simple case. So we're going to ask, what area received snow cover from the storm, and how long did it take to melt to roughly pre-storm levels? Okay, so with that, I'm going to start on this home screen, and I'm just going to type snow cover to search for snow cover. And I'm going to hit enter. Okay, this takes me to what is kind of the main view of Earthdata Search here, and this is a list of data collections that match my search term snow cover. So first of all, if we look at the top of the interface here, we have the same context as we had on the home page. So there's the search by keywords, by temporal, and by spatial, and also the ability to clear our filters if we want to go back and search for something different. So in this case, I'm going to actually also search for temporal. We know when the event happened. It was in January, and I'm going to go a little bit before the storm hit so that we can get a view of what happened leading up to the storm. And so I can apply that filter, that temporal filter, and you might have noticed that over here on the upper right-hand corner, my selected time range has popped up so I can remind myself what I'm looking at here. I can also click this little X button to remove that temporal filter. Also, across the top here, there's a feedback button, which we'll get to later, and the ability to log in using an Earthdata login account. And I'll talk about that in a little bit as well and what that gets you. But for right now, I want to move to the left-hand column here. So this is a faceted search. So the left-hand column allows you to kind of browse through the data in a more guided approach. You can look for data based on what features it might have. So for instance, data with map imagery that we're able to display on the map on the right-hand side, or particularly good subsetting services if you're interested in near real-time data. Scrolling down, if you happen to know the satellite or the instrument that your data was collected from, you can choose those things and further narrow down the search results. So in this case, since it makes for good demonstrations, I'm going to click map imagery and pull up snow cover results that also have imagery that we can display directly on the map. Okay, so that brings us to this central column here. The central column is the matching collections, and I want to go through this just a little bit. So first of all, towards the top, we have this concept of recent and featured collections. We put a couple of collections in there that help you get a good feel for the site based on their feature set. But also, as you're interacting with the site, if you're logged in, it remembers what data you've looked at in the past, and that will help you more quickly find the data that, if you're returning to the site, it'll help you more quickly get to the data that you're interested in. And then down below, there's more collections. So each collection has, if available, a thumbnail, some little indications of what features the collection supports, an indication of how many files are in the collection, and then a couple things that we can do to interact with the collection here. So for instance, I'm going to take this second one here, the Modus Terra snow cover, and I can click on this little eyeball icon. And that's going to show an approximation, and what I mean by approximation, you can read this dialog box if you're going through the site, but it's an approximation of what the data is contained inside this collection. and it displays it right on the map for us. So we can get a quick preview of the shape and size of the files in the collection, as well as the actual contents of the collection. At this point, our goal really is to find a collection that's going to merit further investigation. So another way that we can look into that is by clicking this little information icon, and that will provide some additional information for the collection, points of contact, description, anything that we can glean in terms of science keywords that the collection is relevant to, temporal extent. We can get API endpoints if we want to use external tools and that sort of thing. So going back to the collection list, once I've found a collection that I'm interested in, what I can do is just click on it, and that will take me to a list of files here. And at this point, I want to kind of shift attention, before we talk about what's in these files, I want to shift our attention over to the map view. So one of the most prominent parts of the Earthdata Search display is, of course, the map, because we're interested in geospatial data. The map over here is everything you would expect out of a web map, first of all, so you can pan and zoom, and I'm going to pan and zoom to the east coast of the United States so we can focus in on the area that we're interested in. It has the ability to change layers, so I can change to this corrected reflectance true color layer, which is MODIS imagery that was taken, well, this is actually today's MODIS imagery, and I'll show you how we can change which day is being displayed. And I'm also going to put an overlay on this, so I can put an overlay that is borders and roads so that we can see the shapes of the states through the clouds and get a better sense of what we're looking at here. We can also change projections, so if you're more interested in the North Pole or the South Pole, you can take a look at those. But for our purposes here, I'm just going to look at the geographic projection, which is the default. And then there's a set of tools down the right-hand side here that allow you to choose a spatial area. So in this case, I'm going to put a bounding rectangle over, let's say, the broader DC, Maryland, Pennsylvania, southeastern Pennsylvania area where the storm hit the hardest. Okay, so from here, what's happened as I put that constraint in is you notice that the visualizations on the map have jumped a little bit. So the map is now displaying files that match my search criteria, which now has this spatial constraint on it. So it's only showing me files from the last almost a month that overlap this part of the Earth, and I can see them one by one. I can hover over them to see what the different files are, what their footprints are on the ground, and if I were to click one, it would actually bring that to the top of the blending stack, if you will. So I could actually get a pretty good idea of what's in that file. Okay, so that's kind of answers the question of where is the data spatially. But we might also be interested in where is the data temporally. So if you look down at the bottom of the screen here, we have a timeline view. And the timeline view is meant to answer that question of kind of when is the data as opposed to where is the data. So I can pan through the timeline and I can zoom in so that I'm looking at days instead of the default, which I believe is months. And here I can see that for every day there are a couple of files collected, 2 to 4 files depending. And from there I can click on a single day, and that single day will allow me to see just the files for that day. So this gets what was ultimately, when we began, a very unwieldy list of many thousands of data files down to just maybe 2 to look at. And what I can do is I can use the arrow keys on my keyboard now to arrow between the days. So I can look at one day, the next day, the next day. And as we hit the 20th here, we can see the storm starting to approach off of the coast, because as I arrow between the days, what's happening is the background map layer that I had chosen before is also keeping up with that. So now it's showing what the MODIS true color information was for the 20th. And so as I go to the 21st, we can see the storm is building. If you squint really hard, you can probably see people rushing to the grocery store to buy milk. And then on the 22nd, we can see this is actually when the storm hits, and everything is white because of clouds. And you might also notice that we aren't seeing any snow cover visualizations, and that's also because of clouds. So you have to wait a little bit for the snow to dissipate before this particular product picks up on the snow cover. And so later on, we start seeing, when the clouds are clear, we start seeing a more clear indication of the snow cover in the region. Okay. So once this finishes loading, here we go. I want to call your attention to what's going on in the left-hand panel over here. So the left-hand panel, we've seen what the files look like on a map. Down at the bottom, we've seen what they look like in terms of their time distribution. And then the left-hand side is purely a list of files. It provides information, a little thumbnail for each file if available, the name of the file, which often contains a little bit more information about spatial position or time of collection, data format, and so forth. And then also it provides the temporal extent of the file. And if I were interested in just one file here, if I just wanted this tile, I could go ahead and click the this little download button, and I could get just this tile now. But I'm not going to do that. I'm going to call your attention to the information button, the information icon down in the corner there, which we can click to pull up a little bit more information about what exactly is contained in the file. This is pretty much just a textual representation of the metadata behind the file. Other things that I can do in this list of files here, so if I go back out and I remove my day filter, I can see that we have 46 matching granules, but we notice that there were a lot of clouds. Okay, so one thing that we can do here is, first of all, we can click on a single file, and for instance, we'll just click on this one and we'll say, for whatever reason, we're not interested in this file. Maybe it has clouds, or maybe it doesn't quite cover a spatial search area or something along those lines. We can just hit this X button, or even the backspace key on your keyboard will function the same way. And doing that will remove the file. So at this point, our goal with this set of screens is to pare down this initial list of potentially a huge amount of files into just those files that we're actually interested in getting. And one way to do that is by looking at the previews that are available. I can arrow through on the keyboard and hit backspace as I go and get rid of some of these files that maybe don't contain data that I'm interested in. Now for the particular case of cloud cover, I'm also able to hit this button up here towards the top of this left-hand panel. It says Filter Granules. It looks like a little pencil. And doing that can bring up more advanced filters for the granules in this collection. And for this particular one, there's cloud information. So what I can do is set a maximum cloud cover that I'll tolerate in my results. Let's say we don't want any files that have more than 50% cloud cover. So I can go ahead and hit that and apply that, and my original 40 or so files has now gone down to 8 files that I'm actually going to get when I retrieve my data. So that can be useful as well. We try to provide as many ways as possible of filtering down data. Okay, so from here, if all I wanted were this one collection, I could go ahead and just click again this Retrieve Collection Data button, and that would take me to a screen where I could retrieve this data. but for this demo, I want to show a couple other things. So instead, I'm going to click this plus icon, and that's going to add it to what we call the project. And projects are really a way of intercomparing data from multiple collections or retrieving multiple collections at once. So what I can do is go back to my collection list now, and I can choose a second collection that I might be interested in. So for instance, I want to find, let me remove the facet. Okay. And now I'm going to go down and I'm going to try to find, there's a 8-day product down here that has, it's a level 3 product, which means that there's been some post-processing done to it. It's been moved to, whereas the level 2 product is organized just according to satellite swaths, the level 3 products are aligned to a grid. And in this case, it's an 8-day aggregation of the snow cover information. And so what that does is, before we were talking about getting these individual files and trying to deal with the fact that some of them were cloudy. Well, it turns out that we do a little bit more exploring. We can actually find that in the catalog, someone's already done that legwork for us. And so we can discover this collection as well, and we can get these files. And this is one collection that does not have map visualizations, but it does provide thumbnail previews. So we can still go to, let's say, a day before the storm and take a look, and we can see this thumbnail image that shows where there's land and where there's land without snow, where there's snow, and where there's water. And then we can click shortly after the snow hit and choose a file there, and we can see that the files are all basically either red indicating snow or blue, light blue indicating cloud, where it used to be green indicating land. So this sort of, there's a lot of work that's been done here for us. So I'll go back to my collections list, and I'm going to add that one to the project as well. And I'll just also note that you can, you don't have to stay in the same collection search as you're building up your project. So I could, for instance, be interested in precipitation and type precipitation as my keyword. And then that will search for collections pertaining to precipitation data, and I can choose one of these here, say this one, and add that to my project as well. And so once I have a few collections in my project, I can click this View Project button, and that will let me look at them side by side, see which ones might have extra filters tacked on. So this one has our cloud cover filters that we set up before. They all have different colors associated with them. So for instance, I can draw them separately on a map to see how they overlap spatially. And doing that, the blue one is outlined in blue, which is also blue on the timeline, and I can get a decent context of what I'm looking at when I look at this screen. Another thing that's interesting with projects is that down at the bottom here, we put all the collections on the same timeline. So you might use this to, if you were interested in finding temporal overlap. So you're not so much interested in a broad range of time, but you're also interested in when two collections have data for the same point in time. You can glean that information from the timeline. And one feature of the timeline that I didn't touch on before is that if you find that if you were to just stretch your search a little bit in one direction or the other, if you were to look at the timeline and see that stretching your search in one direction or the other would pick up a little more data you're interested in, you can actually just drag these little fence posts, these red fence posts, and that will adjust your temporal constraint as you go. So that's kind of useful. And beyond that, if you had no temporal constraint, you could just drag along the top of the timeline to set a temporal constraint. So I often find that that's easier than using the date picker, depending on what I'm trying to do. Okay, so let's try to stretch this back out to what we were looking at before. And so finally, when I have all my filters set up in roughly the configuration that I want them in, I can retrieve all my project data, which I just click this Retrieve Project Data button. And from there, it's going to take me to this data access page. It gives me a little preview of what I'm trying to download. In this case, for the first collection, it was 8 granules, and together they're 14.5 megabytes. It has some quality information, and then provides some options for me about how I want to download the data. Okay, so in this case, I can choose to direct download, and virtually all of our information, all of our collections are available for direct download. But many of the collections have additional services that can be performed on them before you download. So if you don't want to download, let's say, all 14 megabytes or however many gigabytes, it's possible that in many cases you can choose a different service option, and that will allow you to perform actions such as subsetting and reprojection, file format conversion. So this particular service, we can choose to, I can choose that I want the files in a GeoTIFF format. I can do spatial subsetting. I can choose to reproject if I want to. I can do band subsetting. So if the collection ties together 100 different parameters and I'm only interested in 5 of them, I don't have to download all 100. So that can be very useful in paring down the amount of data that's coming back to you. So I'm going to click through to go to the second collection. The second collection, just for the sake of time, I'll choose to just direct download, but I could do the same service options on those. And then the third collection is one that I don't have the subsetting capability on, but I can still choose direct download. So finally, I'm going to click through and submit, and it will bring me to this landing page. For the ones that I chose to just direct download, it's going to provide me with download links. If there was browse imagery associated with the collection, I could choose those. I could view those as links too. Because it's not all that user-friendly to have a list of download links, we do recommend that when using this, you either use a browser extension that can help you download a whole bunch of links, or we provide an access script that will, you can run in a shell, and it will pull the metadata and then download the associated files from a single shell script. So it's, we try to make it as easy as possible to just kind of be a almost one-click experience, despite the fact that you're downloading potentially many different files. Okay, the one that I chose to format, convert, and reproject down here is processing. There's some work to be done on the back end before I can actually get those files, so we show a progress bar as that processes. And then finally, down at the bottom, we provide documentation on these collections. So for instance, I can pull up this one, and it will provide information about citing the data, what the data contains. There's a documentation download, which will contain information on the file format, potentially fitness for use for different cases, what you can find in the collection, just more information on how to use the data. Okay. So in the interest of time, I'm not going to wait for this to finish. It usually takes, when I've done this before, it usually takes maybe a minute or two, but in the grand scheme of things, you kind of have to think about what you're not doing here. You're not downloading potentially many megs or even gigs of data that you were not interested in. You're not processing it on your own to cut out areas or bands that you're not interested in. You're not trying to get it from a format that you can't cope with into a format you can cope with. So it's actually doing a fair amount on the back end to support you here. Okay, finally, I want to call attention to a couple other features. We have the ability to save projects. So I didn't show this before, but you can, once you've set up your filters, if you spent some time setting them up, you can save them, and that will allow you to attach a name to them and revisit them later. So you can almost bookmark them that way. We also support bookmarking of just about any page that you've seen, and it'll keep track of your search filters and so forth. If you didn't happen to bookmark, but you did retrieve the data, we allow you to view your recent data retrievals. So this will take me back to the same page here if I click on my recent data retrievals. And that is also potentially a way to kind of find your way back to wherever you were last time. Okay, so I think at this point, I really need to wrap up, but I kind of want to go over what we've done here. So we've taken an archive that has petabytes of data, and that data is contained in hundreds of millions of files. And we found a few files that we need. We previewed their data to make sure that they contain what we want. We removed some of the extraneous data from the files, and we transformed them into a usable format. And so with that, Earthdata Search has made significant strides towards managing that fire hose of data I mentioned earlier. But I personally feel like we can do even better, and we are very much trying to do even better. And to that end, we'd appreciate your help in improving the client. So there's a couple ways that you can help us. First of all, there's this feedback button in the upper right-hand corner. If you're going through the site and you find something that you find particularly helpful, or if you find some rough spots, we want to hear about it. So please, fill in some feedback for us so that we know what's going on. There's also a survey question that will be coming up about participating in a usability study. If you're interested in helping us in that regard, particularly if you're a science user interested in helping with our usability study, please fill out your information there. And then if you are more of the developer type, I should note that we are open source, and all of our source code is available on GitHub, as well as a few of the components that we've built. So the timeline component, for instance, is its own separate project in GitHub. So take my code, please. All right, so thank you, and with that, I'm going to turn it back over to Jennifer.
Okay, thank you, Patrick. Thanks, everybody. So what we'll do next is we will move to the final set of polling questions. And I'll give these questions just 2 to 3 minutes or so. And then from there, we will move on to the Q&A portion of the webinar. So be sure to stay in the room and/or stay on the line to participate in the questions and answer period. All right, let's give these a couple of minutes. Thank you. And just a really quick note on the usability testing question. I opted to not broadcast the results for that polling question just for the privacy of any participants who may not be wanting to share their email. So we can see it, and obviously you can see your own email, but you're not alone. Okay? Thank you. Okay, I'm going to give these questions just another minute or so, and then we'll move to the question and answer period. Okay, everybody, we are going to go ahead and move along now to the question and answer period. All right, let's see here. So one of our first questions is, will you post this presentation? And the presentations, if you look in the lower right-hand corner of your screen, you will be able to download the slides by, left-clicking on any of those. There's the agenda, there's the, few slides at the beginning of the presentation, and then my slides. And then you'll be prompted with an option to download the file. With respect to the webinar itself, I did record the webinar. I should be able to take out the, the gap in time that we had in trying to share the screen. And that will be posted to not only our NASA Earth Data catalog, which you see here to the left, the tinyurl.com Earth Data webinar, but also we have a NASA Earth Data YouTube channel. We've got, I think we've got probably 55 or 56 data discovery and access webinars posted there currently, so you could check that out. All right, so let's see if we've got any questions here. Okay, the first question, Patrick. Let me just scroll down a bit. Is there a web service that can be used to automate download of layers and data? It's kind of a two-part question, so why don't we take this piece first?
Okay, so that's the first piece, is the web service to automate downloading of layers and data.
Yes, and then it's further, in addition, can custom maps with user-chosen layers and data be embedded into a website? Can I add my own layer, points, or raster for comparison?
Okay, so the answer, I guess, is it partly depends on what you mean. Earthdata Search uses another NASA service called GIBS for its visualizations, and that it exposes a WMTS endpoint, which is very similar to WMS. You can embed those GIBS layer really in any popular mapping software, especially web mapping software. It's very easy to use. So in that sense, you can definitely get a hold of those visualization layers. If you're talking about more layers of the data or a more bulk download capability, the answer there is that it varies by collection. But many of the collections, like for instance the snow cover one that I showed, once if I had allowed that service to finish, once it was done, it would have provided me a zip file to kind of bulk download all of it, and that is also exposed as a web service that I can't recall off the top of my head if that's public facing. I believe it is though. Okay, and so if you remind me, the second part of the question was?
Can you, in addition, can custom maps with user-chosen layers and data be embedded into a website? So can you add your own layer, points, or raster for comparison?
Okay. So I guess I should go back a little bit. In terms of Earthdata Search and what it provides, virtually anything that you do is bookmarkable. So if you've done something in the site to set up a particular set of layers, you can share that with someone else through the URL. And I think that's about the extent to which we provide an API. And we don't really do anything in particular to support embedding. but you know, Gibbs itself is basically meant for that use case. So the underlying visualization layers that we're using to draw on the map can definitely be embedded in your own site.
And Nicholas, although we obviously want you to be using NASA Earthdata Search, if there are specific data products you are looking for, there are possibilities that that type of functionality or web service may exist at the specific DAC that may distribute those data products. If you want to follow up with an email to me offline, I can try to provide some additional information on that. The next question is there a possibility to make selection based on criteria? For example, is there a possibility to pick reflectance value for specific QC values?
No, not at this time. We don't do, we deal with searches on the metadata, so we can look at really anything that's provided at the file level, but once it gets down to the pixel level, that's not something that we can currently support.
Okay, thank you, Patrick. The next question is, will we have documentation about the site usability? So I'm assuming for those individuals, Billy, if I don't have this correct, please correct me in the Q&A pod. For those individuals who opted in for usability testing, they might be interested in some results from that usability testing. Is that accurate, Billy? Yes, okay. Patrick?
Yeah, so if you are participating, we're not just going to leave you hanging. I think that's fair to say. For the broader, I believe, in terms of sharing the overall results, I don't have an answer to that at this time, but I could check with people who would know and get back to you.
Okay, great. Thank you, Patrick. The next question is there any convenient way to subset and download MODIS datasets for an entire time range for more than 100 sites?
Convenient way to download MODIS datasets. I'm sorry, can we?
Subset, is there any convenient way to subset and download MODIS datasets for an entire time range for more than 100 sites using NASA Earthdata Search?
For more than 100 sites. I'm not sure I understand that more than 100 sites piece.
So more than, I'm not sure if you're referring to, for example, wrong. There is a capability at the Oak Ridge National Laboratory DAC. It's a MODIS global subsetting and visualization tool. I'm not sure whether or not there is a maximum quantity of field sites that you could subset, but you can certainly subset. So I could follow up with you offline on that one. So I think that's, do I have that correct? Wrong? So you have more than 100 geographic regions for which you are examining for your research, correct? Or are you referring to flux sites or other field sites? Yes, okay, good. Right, like the Oak Ridge DAC tool, okay. So is that a capability within Earthdata Search? To be able to, select that many locations and then be able to download the data?
So right now we don't have any hard limits imposed on the amount of data that you're able to download. So it's just a question of whether you could set up the filters appropriately, and then also whether the data providers themselves have hard limits. Often depending on what you're trying to do with them. If you're doing transformations of the data, there might be caps on how many files you're allowed to request at once. But for direct download, really the only limitation is the filters that you're able to provide to the client. And I guess if you're finding that the filters that we do provide are inadequate for your needs, that's something that we would want to hear, if there's a use case there for.
Also, I just wanted to add that there is a tool in beta format right now at the LPDAC called Appears that allows for MODIS data extraction for point-based, for specific points, although, again, I'm not certain as to how many points you could actually enter, but certainly I can put you in contact with them for further inquiry. Okay, Rong? And then let's move along to the next question. How does CMR relate to Earthdata Search?
Okay, good question. So CMR is the back end of Earthdata Search. We primarily talk to CMR for all of our collection and granule search. It's where we get our metadata. It's really everything. It provides the timeline information as well. Basically everything except for the map visualizations, which are GIBs, and the subsetting, which are handled by the data providers.
I'm sorry, Patrick. I just want to make sure, for some people may not be familiar with what CMR actually is. Could you define that, please? Thank you.
CMR is the Common Metadata Repository. So it is the repository where all of EOSDIS metadata goes for the EOSDIS collections and granules. And on top of that, it provides a bunch of programming interfaces that allow you to very quickly search through the data, do things like our keyword search, temporal spatial searches. One of the things that it features is sub-second granule search. So it's able to take really pretty much an arbitrary search within reason and filter out from hundreds of millions of granules to find the granules matching that search. So it's pretty impressive in that regard.
Okay, thank you, Patrick. The next question is it possible to mosaic MODIS data sets in the process? As one of your services, after you've ordered MODIS data, is mosaicing a capability?
It depends partly on the collection that you're talking about and whether it has a configured service that is capable of doing mosaicing. That's something that would happen on the data provider side and that we would act as a client to. But certainly those sorts of capabilities are things that we're interested in extending the client to be able to do as much as possible. So if there are services out there that are useful, then I'd say at some point, if not now.
Okay, thank you, Patrick. The next question is, can you talk about the zoom scale? What you have now is not useful even at a county level.
Great. So our zoom scale is very much limited by our map layers, which are provided by GIBs, and it is, at this point, it is a kind of known problem what the questioner is asking here, that we should be able to zoom in further, and it's, on our end, it's just a matter of getting imagery down to that level that we can use.
Okay, thank you, Patrick. So I'm looking through the list here. Are there any further questions? I'll give everybody just a minute or two just to see if you can think of anything. And then just to, what will happen next if there aren't any further questions, what we'll do is we'll hang up from the telecon itself. However, I will leave the virtual meeting space open for another 10 minutes or so. So if you are interested in downloading the file or you think of an additional question, please feel free to enter those. Okay, enter those into the Q&A pod, and certainly we can address those offline. And obviously, feel free to email me and any questions that are questions that Patrick could address. I would be happy to forward those emails to Patrick. You do have a question, actually. Is it possible to schedule a subset and download it without entering the site?
Without entering the site. That is a service capability that I'm not sure about, to be honest. It's kind of...
So I think we'll need to look into that, Billy, and get back with you. Okay, so hopefully in the next couple of days or so. Okay, sure. All right, any further questions? Okay, we actually do have a webinar coming up. Let's see here. Oh, you're very welcome. We do have a webinar coming up on the 24th of February where our NASA Global Hydrology Resource Center will showcase a tool that's currently in beta, and it's a tool that's meant to access NASA's field campaign data products, and specifically they'll be focusing on the Hurricane Sentinel project. So that's something, you know, for those of you who are signed up to the email listserv, you'll receive some information about that webinar soon. All right. I do have a comment here. Download menu is disabled. I assume it will be active at the end of the presentation. Download menu. For the files, you should be able to left-click on a file, RAM or ROM, and when you left-click on the file in the file sharing pod, if this is what you're referring to, you would be prompted to download the file. Let me know if that works, if that's what you're referring to. If not, let me know what you are referring to. I can be more helpful. It's very nice to see some of you who've been to, a large majority of our webinars over the last couple of years. So welcome back. I know we took a break over the holidays and we had some schedule conflicts, but we are ramped back up. None of these glitches ever happen during the dry run, but on occasion this occurs. I hope to see you at a future webinar. If there are no further questions, we will hang up from the telecon. And again, I will leave the virtual meeting space open. I'd like to thank all of you who are new to the webinars and attended for the first time today. Thanks for showing up. We were glad to have you. All right, doesn't look like there are any further questions. All right, everybody. Let's see, I'll just give it one last look. All right, thanks everybody. Bye-bye now.